Hi, I'm Grant Bailey from Revo Group, and I'm here to tell you about an interesting project that we completed for CitiPower and Powercor recently. CitiPower and Powercor got us involved on this job to help them make a more informed, confident decision regarding their uniquely fabricated 66 kV steel termination poles. To help inform the decision-making process, CitiPower and Powercor required a detailed assessment of the poles, including a detailed pole top condition assessment, above-ground defect detection, and serviceability index rating. Powercor asked us to help on this job due to our expertise in steel pole inspection, durability, and overhead line design, as well as our ability to scope and process photogrammetry and LiDAR data for ultimate serviceability assessment. The poles provide critical underground to overhead connections for Geelong and Melbourne. Since the underground cables are oil-filled, the cost of doing any remediation works involving the cables is enormous and warrants spending a little more on a detailed investigation. Not to mention the work was required to be completed during COVID shutdowns in 2020 prior to the summer season, otherwise they would lose that year's window for de-energising and repairs. The first stage of the project involved capturing as much data on site for the inspection and serviceability assessment as possible using photogrammetry and LiDAR techniques. Despite having some internal capabilities, we chose in this case to work closely with local drone services company Australian UAV to ensure that all the specific requirements were met. Having our own qualified drone pilot in-house allowed us to scope the task and manage the expectations of all involved to capture the best data for the assessment. Next, one of our qualified inspectors captured residual steel thickness data out in the field. This process was complicated due to the COVID-19 and interstate restrictions. However, our agile team was still able to gather all the data with minimal delays. While the thickness data was being collected, our engineering team started building the 3D finite element models, near-align design models, and reviewed the photogrammetry data required to properly analyse the bespoke fabricated poles. The high-resolution images enabled a high-quality photogrammetry image to be developed, which was used to scan for potential issues, and individual images of the defects were further analysed to determine criticality. This data was then amalgamated into a detailed analysis report with the remediation designs and recommendations for each pole. Only one pole out of the three required additional reinforcement and shield poly pole coat coating due to the extent of the corrosion, and no poles required replacement with the design life determined by Powercor. In summary, to analyse the poles for residual strength and compliance with old and current standards, we used LiDAR to capture the line profiles and conductor tensions, NERA to model the loads on the pole from the 3D LiDAR data, S-frame to model the steel stresses in detail, particularly around the base plate connection, ultrasonic thickness readings for quantifying residual strength, corrosion extent, visual inspection around ground in person, visual investigation of the pole tops from the photogrammetry data. This was a bespoke project, but we have a system in place now that can provide an exceptional level of detail with minimal cost. Contact us to find out how you can dramatically reduce your overall asset inspection and management costs compared with current segmented techniques. Revo Group, delivering a revolution in reliability.